Hello, and thank you for attending our lightning talk on counting aircraft operations and analysis of tracking tools for North Carolina airports. I'm Chase Nicholas, and today Ryan Hassett and I will be presenting on behalf of our research team at the Institute for Transportation Research and Education at NC State. Our research team also includes Daniel Findley and Ishtiaq Ahmed. In this presentation, we're going to summarize our research to date on a project we are conducting with the Division of Aviation to evaluate new operations tracking systems that are poised to change the way aircraft operations are recorded throughout the state. So how exactly are operations tracked in the North Carolina airport system? The answer is it depends. Air traffic control provides airport operations counts at towered airports that have air traffic control. However, most airports in North Carolina's airport system are non-towered, and you can see the distribution of towered and non-towered airports in the map on the right. Non-towered airports typically lack systems for consistently recording operations data. When they're needed, operations figures at these airports are estimated, typically from the number of aircraft based at the airport. So better operations tracking systems and data can support both airport management in terms of runway management and safety and security, as well as assist NCDOT broadly in the prioritization of state and federal funds for infrastructure development, as often these funds are tied to operations counts. Finally, better tracking technology will yield better data at towered airports, where automatic tracking is likely to be better than manual counts. Automated tracking will also support towered airports that may not have manned air traffic control on a 24/7 basis. One of the historical challenges with operations tracking is the physical technology used to identify aircraft and their locations. For new generation aircraft, this isn't as much of a problem. New generation aircraft are equipped by default with ADS-B out transponders that transmit GPS-derived location data from the aircraft at regular intervals, typically less than a second, which helps to greatly improve aircraft location tracking on the ground. However, many older generation aircraft, of which we have many in North Carolina, are still equipped with identification-only transponders. And those transponders emit only a unique identifier for the aircraft and not location info. And that's despite the fact that we also have an ADS-B equipage mandate in North Carolina, which requires older generation aircraft to be retrofitted with ADS-B out transponders. So we actually have multiple services now that are available to NC airports that are capable of tracking both transponder types and actually of giving decent location data, whether or not that transponder is using ADS-B out or identification only. As I mentioned, there are multiple services available on the market for providing hardware and software support for tracking and storing real-time operations data at costs that are accessible to smaller non-towered airports. And the typical installation looks similar to the image on the right. These services deliver really rich data and analytics features. And the example of one of the dashboards that's built into one of these services is shown in the bottom right on this slide. We need to analyze these services, however, including doing a truthing of the data to video footage review to provide insight on the data validity and also to compare these services to each other. So I'm going to send it over to Ryan Hassett, who's going to present a summary of our analysis to date.
Thanks, Chase. Our work so far at a general aviation airport in coastal North Carolina has already given us two key insights into the performance and utility of these services. First, the correction of a less than ideal hardware installation demonstrated how the performance of these vendors' products can vary substantially based on install conditions. Second, the introduction of a third service, one that only incorporates ADS-B data, has allowed us to start to estimate ADS-B penetration among sensor-equipped aircraft, at least at this airport. This airport had receivers provided by two different vendors installed. However, their installations were not comparable. Vendor 1 had the antenna placed poorly, with the device relying on a distant Wi-Fi access point to transmit data. Vendor 2 had the antenna placed outside in a known good location and the device's network connection was hardwired with an Ethernet cable. In mid-June, however, an outage of the Wi-Fi connection to vendor one's equipment caused the airport to decide to reinstall the equipment in a location comparable to that of vendor two. Before the relocation, vendor one was capturing only about 60% of the operations and unique aircraft captured by vendor two, with the share varying widely day to day. After relocation, vendor one and vendor two have comparable performance, with the information captured by the first vendor almost identical to that captured by the second. This graph shows the poor performance of vendor one, shown in red, prior to the relocation. While on some days its performance is comparable to that of vendor two, on many days there's a meaningful gap, and on a few days, such as the days right before the internet outage, that's towards the end of the period shown, it collected almost no information at all. After the reinstallation of the equipment, we can see that the two vendors performed virtually identically, except on a handful of days. What causes one service to significantly outcount the other on those handful of days remains unknown, but we are hoping to use video footage to uncover the answer about what affects this performance. A question that had previously been unanswered was the penetration of ADS-B transponders. As Chase said, despite mandates, these are not yet universal. By introducing information from a third vendor, one that only tracks ADS-B transponders, and comparing it with that of the previous two vendors, we were able to determine that the vast majority of sensor-equipped aircraft at this airport are equipped with ADS-B, at least 9 in 10, and probably more. Here we can see not only how vendors 1 and 2, indicated in red and blue, perform similarly, but also how total operations from vendor 3, the one which only tracks ADS-B aircraft and is shown here in green, generally only slightly lags that of the other two services.
Thanks, Ryan. Our research with the Division of Aviation is ongoing, but we've already answered some questions that we hope will help the DOA as it supports the airport system and its adoption of new tracking technologies. First, we've determined that hardware setup and connection play a major role in data quality. Second, we found that multiple vendors may offer roughly equivalent data quality when they have equivalent hardware setups. And finally, we've also found that ADS-B out-equippage appears high, at least at one coastal general aviation airport, but that may vary between airports, so this question requires further research. Our next steps primarily are to conduct a video review to validate vendor data quality with direct observation, and also to continue our review and comparison of additional vendors in the market. We're hoping that our research will provide the Division of Aviation with the information it needs to significantly improve operations tracking in the North Carolina airport system. Thank you.